I'm Megan Keys, National Account Manager at Johns Manville, and I will be your moderator for today's presentation. Today we'll discuss how continuous insulation wall systems can address the changing building codes. This presentation will help to take the guesswork out of what makes a perfect wall in all different applications. Joining me today is JR Babineau, who will take us through details to help you understand the building science behind the systems for Johns Manville continuous insulation applications. I'd now like to turn it over to our presenter, JR, who will take a few moments to introduce himself.
Thanks again, Megan. My name is JR Babineau, and here at Johns Manville, I work in our corporate R&D group, and I am our building scientist and research manager. So in that role, I've been here for 21 years. I end up supporting the insulation business, both from a testing perspective. We run several testing labs, but also helping to make sure that how our products get used results in a successful building, right? That we're not having our customers do things that are going to end up causing them problems. And so that's some of what we're going to make sure that we cover today. So moving on, just real quickly in terms of today's topics, we're going to do kind of a brief refresher on kind of the building science behind continuous insulation, right? So what sort of problems are in the building envelope today in a lot of commercial buildings, and how does continuous insulation help address that? Then we're going to talk next about the different sorts of exterior continuous insulation products or systems that are out there. We'll talk a bit about why these different materials might be specified over one versus the other, right? Some of the pros and cons. And then finally, we'll touch on a few examples of buildings that utilize some of these different strategies. So jumping right in, first off, right, the main reason that we see continuous insulation get specified, get used in commercial buildings is really to address what we call thermal bridging. So the building codes, right, that's really the goal that they're trying to get at is, and the second bullet point really hits at what's going on in commercial buildings today, right, especially buildings that are done with steel stud infill or pre-engineered metal buildings, right, where we have a lot of highly conductive metal, right, that metal conducts the heat around the insulation. So even though we might put mineral wool or fiberglass bats or spray foam in the stud cavities, in the framing cavities, the heat's able to go around the insulation material. So even though it's trying to do its job, the structure is kind of defeating that a bit. And the real common offenders for thermal bridging are, again, things like steel framing, balconies that are basically extended floor slabs, slab edges, window frames, right, anytime where we have material that is going to be way more conductive to heat than insulation. And the kind of the drawing here all the way on the right side of the slide highlights the real driving issue, why the Energy Code needs to address this, and that's because our framing could easily account for 25% of the total area of a given wall, well, framing and things like slab edges. And so that can really cause a lot of excess energy use, as well as some of these other comfort and indoor air quality issues we're going to talk about next. Just to kind of, again, reinforce this, we showed the photo of the frame, the steel stud framing on the previous slide, but on this slide really highlights some of these issues with concrete floor slabs. So the regular photo images on the right, and then or on the left, and as we move to the right of the slide, we get to infrared images. And in particular, on the top row, the photo and then the infrared image are of the same building. As this was being built, I was able to snap a shot during the summertime when the building was going up. Later, I came back in the winter with an infrared camera, and we can really see that these extended floor slab edge balconies, right, really do act as fins, taking heat from inside the buildings and dumping them to the cold outside air. So in addition to just energy use and comfort, thermal bridges and continuous insulation help a lot with condensation control in our walls in particular. And so first off, we'll look at a cold climate, and if we look over here on the left side of the slide, the important things to look at are outdoors, right? We're going to assume it's 20 degrees, it's cold, it's wintertime. Indoors, it's 70 degrees, right? 40% relative humidity, which is moderately dry, I think, depending on where you're living, right? But that means that the dew point of that air, the temperature at which the humidity in that air wants to condense, is 45 degrees. If we look inside of our wall at the back side of the sheathing, if we just insulate the stud cavities, that surface might easily be 25 degrees, right? Because all the insulation is inside of that, so that outside wall is going to be pretty close to the outside temperature. And of course, when we get that humidity kind of diffusing through the wall, or worse yet, if it's kind of carried through there by an air leak, right, we can easily get condensation. We get the drops of water forming on the sheathing. Ultimately, that ends up being, can be very damaging. Right, when we add continuous insulation to the system, though, right, we help things out a lot. Now we see that the backside of that sheathing could easily be warmed up to something like 50 degrees or even warmer. So now it's above the dew point of that inside air. And this is the important difference, right? We don't want the inside air to see any surfaces or to encounter any surfaces that are colder than the dew point, right? And so now when any humidity kind of diffuses through into this wall, everything that it encounters is going to be warmer than the dew point, so we're not going to get any condensation. Now the dew point is pushed somewhere out into the insulation, but continuous insulation, but now the humidity will never reach those spots, right? So basically, now we've brought all of these, we've brought all of these elements inside the wall kind of indoors into the conditioned space. Similarly, we can run into another problem related to this in hot, humid climates. So in this slide, again, looking on the left, right, outdoors, we've got a very hot, humid condition, 90 degrees, let's call it 85% humidity, which means the dew point could easily be 85 degrees. Indoors, right, it might be 70 degrees, 50% relative humidity. We've kind of made this problem even worse than normal by putting like vinyl wallpaper. The yellow line in this drawing is meant to represent some sort of vapor barrier wall covering. And now, right, in this situation, the humidity wants to come in from the outdoors. It's going to see the backside of that interior drywall that is going to be the same temperature as the inside. Could easily cause condensation. And of course, if we have vinyl wallpaper, we can get a situation like in this photo now on the right. Right, this is actually one that I took this photo just earlier this year. I was in a hotel in a hot, humid climate. It did not take me long to find a spot where the wallpaper would easily peel back, and we see, right, little bits of mold beginning to form and grow in this particular spot. This is a really common problem in these sorts of climates. That's one of the reasons why a lot of hotels and places are going away from vinyl wall coverings, because of these issues. Again, though, if we add continuous insulation to the outside, especially if it's foam plastic insulation, now, again, everything is in the conditioned space, and the foam plastic materials help keep that moisture outside, right, so it cannot get into the wall cavity, and then any little bit of moisture that might actually be in here can dry to the inside, so long as we get rid of that vinyl wallpaper. So again, foam plastics, and we'll kind of get into the different materials here in a minute, but foam plastic materials will tend to keep this moisture out. Mineral wool materials would let it in, but again, that can be not a horrible problem so long as we don't trap the moisture inside the wall. Kind of the final building science issue that I want to talk about that continuous insulation can help address is, rather than just condensation in the wall because of the climates we're in, really condensation can be actually caused by thermal bridging, right? So again, if we start here at the left, we see these photos of steel framing, or in the photo there on the bottom, extended floor slab balconies. right, if we move on over to the middle, right, we've got our infrared image, and that's really showing, right, where the thermal bridging looks like warm spots when we look at it from the outside with a thermal camera. But if we flip that around and we look at it from inside the building, we get situations like the photo on the right, where now we have cold spots. So from the outside, that framing looks like it's warm, but on the inside, it's actually cool. And the photo here and the dark stain in the corner of that wall, that's from a cold spot due to steel framing causing resulting in thermal bridging. And that cold spot was sufficiently cold that we got condensation and ultimately a bunch of mold growth in this particular spot. The photo, just to give a little more background, this was actually a closet. You know, the kind of the hardware has all been removed and everything, but the clothing basically inside that closet was acting as better insulation than what was in the wall itself. And so we had this very cold spot where the framing all came together, right? And obviously this results in, you know, indoor air quality problems, things that we don't really want to have happen in our buildings. Continuous insulation on the outside would have addressed that or prevented this from happening. So we've been talking a lot about continuous insulation and throwing this term around, and right now we're going to give kind of the one dry definition part of the webinar today. So this is from ASHRAE 90.1, which is one of the real de facto energy codes for commercial buildings used across the U.S. And within ASHRAE 90.1, right, they actually define what continuous insulation is. So as you could imagine, it's going to be insulation that's continuous across all of our structural members without thermal bridges other than fasteners or service openings. It's important to note that continuous insulation can be on the interior or the exterior or can be integral to the building itself or to the building envelope. And we'll talk about how those different things can manifest themselves in a minute. And then moving on now to continuous insulation types. So first, just from a generic perspective, there's kind of three big buckets of materials that can be used as continuous insulation. There's rigid foam board, and in the rigid foam board category, there's a lot of different materials. There's polystyrenes, there's polyisocyanurates, there's even materials beyond that. I would say one of the more common ones, and the one that I'm going to be talking about as Johns Manville solution, is polyisocyanurate foam board. There's also spray foam. Closed cell spray polyurethane foams can actually be used as exterior, or interior, as continuous insulation. And we'll talk about that in a minute as well as we dig into these. And then finally, mineral wool. So semi-rigid mineral wool boards can easily be used and are often used as continuous insulation on the outside of a building. And so Johns Manville actually has got several options for covering all three of these product categories. So in the foam board category, here this first product column, Johns Manville has got two polyisocyanurate foam products. One is called AP Foil foam sheathing, and the other one is called CI Max. Both of these products are polyiso foams. The only real difference is in the facers that we use, and those differences, slight differences in the facers, result in some different fire approvals. But other than that, those products are basically equivalent from a thermal performance perspective. On the spray polyurethane foam side, Johns Manville's Corbon 3 product works really well as an exterior foam sheathing, and we'll get into that in a minute. And then finally, on the mineral wool side, we have our Cladstone product, which again is a semi-rigid mineral wool board that can go up on the outside of a building. And so I'm going to take a few minutes. We're going to kind of talk through this table for a minute, just to highlight, right, some of the differences in terms of performance between these different product categories. So first off, looking at R value, right? So that's the thermal performance of these different materials, right? Higher R value means more insulating power. And so for the polyiso board products, they deliver about R6 per inch, which is definitely one of the highest thermal performances you can get out of foam sheathing materials on the market today. Looking over then at Corbon 3, right, that actually delivers an even higher level. That's 7 per inch. And then Cladstone is at 4.3 per inch. And it's not that that's bad, that's just different. And the real, what this means is that depending on the product you choose or specify, you're going to need a thicker or thinner amounts of product, on the wall to hit your R value target. Next is this function of WRB. That stands for a water resistive barrier, right? That's something that all buildings have to have. They need to be able to keep rain out of the building. Foam board products like AP foil can absolutely deliver that functionality so long as we include with them some flashing tape, right? We need to tape the seams, we need to tape the fasteners, we need to use sealant or canned foam to deal with any penetrations. But those can absolutely deliver WRB performance. Same thing with Corbon 3. There we don't need the tapes, of course, but we do need to still be sure we're flashing our window and door openings, and then when the Corbon 3 gets sprayed on, it will adhere to that flashing and create kind of a continuous drainage plane for that wall. Cladstone, for both WRB and air barrier, does not deliver that function. Cladstone does resist water, and it's very drainable. But for a Cladstone system, those typically are rain screen, and so we'll talk about that more later in some detail, but there'll be other materials that will need to be installed on the wall to make sure that we deal with rain. Similarly, air barriers, right? So commercial buildings anymore, there are requirements for air tightness. AP foil and CI Max can absolutely be part of an air barrier system, and actually these products and Corbon 3 have both been tested and are listed under the Air Barrier Association of America, sorry about that, website, right? So that means we've gone through all of the both small scale and full scale testing for these materials to qualify. Similarly, right, Cladstone, like we said before, is not an air barrier. It will need a separate air barrier in the system. Vapor permeability. This is another functional category where these materials vary quite a bit, right? So our AP foil products and CI Max products, being foil-faced, have a very low water vapor permeability. These are effectively vapor barriers. And so that's not a bad thing, but it just means that we need to be aware of that, and really the designer, the architect, or the specifier needs to be aware of that when they're designing this wall system. Corbon 3, it can be a vapor retarder, but it's got to be thick enough. So the vapor perm of Corbon 3 is 1.1 and only 1 inch, which right there, that's a little more permeable than would be a vapor retarder. But certainly as we get to thicker materials, thicker amounts of Corbon 3, that perm will then go down. And again, we just need to be aware of that from a design perspective. On the flip side, Cladstone is extremely vapor open, right? As a mineral wool material, it's very open. Water vapor can pass through it very easily. Again, that can also be a good thing depending on the climate and what sort of system we're designing. Finally, fire is always an important consideration when we're talking about commercial buildings, and both AP foil, CI Max, and Corbon 3 are all foam plastic, so they clearly burn. The numbers that we're showing here on the table are the results from the E84 tunnel testing that has to happen. These materials also actually go through larger scale fire testing as well to the NFPA 285 standard. And so that's an important consideration. Again, on the flip side, Cladstone, being mineral wool, is a non-combustible product. It has a 0 flame spread, 0 smoke rating, and so it doesn't necessarily have to pass all of these large-scale tests, but in some cases we do still test it with some systems that we'll talk about more in a minute. One more kind of word about condensation control with continuous insulation, and that is actually to the point of drying. So the question here often is, how can my wall system dry if, let's say, I've got foam sheathing on the outside? So the top drawing, right, is really highlighting if we have either foam sheathing or spray foam. So the drops in the drawing here are really representing rain leakage, not condensation now, right? The biggest threat when it comes to water to our buildings is by far rain. It is not condensation. And you know, what we need to be aware of is if rain gets, especially, I'm going to get my pointer visible here for a second, right? If we get, let's say, some rain that gets back behind the foam sheathing, right? There's some defect in the flashing, there's some little leak somewhere, we get some water back behind there, you know, we don't want it to stay there forever because ultimately that's when it causes problems. So the idea with using foam sheathing or spray foam on the outside of our walls is that then those walls should be able to dry to the inside, right? And so the temperatures we're showing here represent winter, but really in any season, right, we want that water to be able to dry to the inside. We don't want to put an interior vapor retarder on a system like this. Kind of conversely, right, with the drawing on the bottom is meant to represent mineral wool being on the outside of our wall. Again, same situation, right? We can have water out on the mineral wool, water could get back to the backside of the mineral wool potentially. Hopefully back here is where we have our drainage plane, right? Whether that's a sheet good, like a building wrap or a liquid applied. But again, any water that gets into a system with mineral wool really can dry to either direction. And ideally, we would want to allow it to do that. We'll talk about that more in a minute as we do a little more of a deep dive into mineral wool. So as we mentioned before, right, the real driving need for continuous insulation comes out of the energy code, right, and that is driven by climate zone. So we're not going to look at every possible combination and permutation here, but on this slide, what we're showing is some examples. The table on the left is got for both mass walls and metal framed walls, you know, and that's really going to cover most of the commercial buildings that we're talking about in the U.S., right? So a mass wall could be a tilt-up wall, could be a poured-in-place concrete wall, could be a concrete block or CMU wall, right? Any sort of heavy assembly that's not steel frame, right? And so what we're showing here is over the course of time how these continuous insulation numbers have changed. The highlighted columns are obviously for the most recent versions of ASHRAE 90.1 or just the energy code, the IECC, and those two codes tend to resemble each other a lot. The other part of the table, metal framed walls, that is our common steel stud infill, right? That's a metal framed wall. So this is not a pre-engineered metal building. That actually has its whole own category. I didn't include that on the slide, but there's a very similar expectations for continuous insulation. The numbers in the table represent R values, right? So anytime we see CI, like under the mass wall, or in the metal framed wall, the number that comes after the plus, right? Those are our requirements for continuous insulation. In the metal framed wall, the 13s that we see everywhere, that's for cavity insulation. So the assumption there is that that's going to be an R13 fiberglass bat or a mineral wool bat, or it could be spray foam, right? But something inside the cavity. And again, final point, right? These are the prescriptive values, right? Lots of times what we see specified on buildings might be different than this, right? There could be trade-offs that are being used in different parts of the building envelope versus, say, the roof or the windows, right? Different approaches can be used where these numbers won't be exactly what's specified, but this is always a good starting point. And then, of course, right, this all varies by climate zone. So on the right-hand side, we've got a map of the U.S. It shows the different climate zones, right? And then as we go from the low numbers or the warmer climates, the high numbers are the colder. And what we're going to do is just touch on over the next couple of slides kind of what that means, what these requirements mean in terms of product selection. So on one end of the spectrum, right, climate zone 2, that would be hot. And in much of the country, right, areas like Texas and the Gulf Coast and Florida, that's hot and humid. There is also hot over in areas of Arizona, right, where that's hot and dry. But if we look at then the climate zone needs and continuous insulation needs by climate zone for an area like this, and there's certainly a lot of construction in this climate zone. If we talk about a mass wall, right, the code's going to call for at least R5.7 of continuous insulation. That can be inside or outside. If it's a steel stud wall, it's only calling for R3.8. And again, this is just regular commercial. This is not residential occupancy. This is not necessarily apartments or things like that. Those sometimes have a little different requirement. But what does that mean in terms of some of Johns Manville's products? So if you're in climate zone 2 and if you're wanting to do AP foil or CI max, what that means is we're looking at 1 inch or 3/4 of an inch, depending on whether this is a mass wall or a steel stud infill wall, right? So not terribly thick, pretty easy to handle and deal with. If we're talking about Corbon 3, right, to just meet the R value, we're talking less than 1 inch of spray foam. Now, I will tell you that in reality, we're almost always going to see at least 1 inch of spray foam put on. One, to get less than 1 inch is really a challenge. You got to have a really good installer. And also, we need to have at least 1 inch for the Corbon 3 to qualify as an air barrier. So typically, if we did Corbon 3 on any of the buildings in this sort of climate zone, I mean, this is not a bad thing. It's going to end up we'll be delivering more R value than what the code minimum requires, which could allow trade-offs in other areas. Similarly, our Cladstone product, right, 2 inch is kind of the minimum basic thickness that we have. I think we might offer some thinner materials on a project-by-project basis, but in terms of a basic material, 2 inches is it, which comes in at R8.6. So again, we would be beyond the code minimum. Right, again, these questions of WRB and air barrier, again, as we talked about before, AP foil can definitely be a WRB or an air barrier. CI Max is absolutely an air barrier as long as we tape them. Corbon 3, again, we need at least 1 inch. Right, all of these things, kind of the boxes all get checked pretty easily. Finally, fire, right, again, as we talked about before, the foam plastics, AP foil, CI Max, Corbon 3, all have and need to have these NFPA 285 fire test approvals. We kind of jump up to the north side of the country. The main change that we end up seeing, and we get this kind of in climate zone 6 and in zone 7, but we'll kind of talk about it more here on zone 6. One, obviously we get cold winters, and so there's a much greater demand for higher R values for these materials. So for mass walls and steel walls, right, we're looking at R values of 13 or 12.5. That drives obviously much thicker materials. We're looking at 2 to 2.5 inch thick foam sheathings, right, whether it's AP foil or CI Max. We're looking at almost 2 inches of Corbon 3 on these sorts of assemblies, and we're looking at 3 to 4 inches if we go with something like Cladstone. In terms of air and water barriers, right, those things don't change, but permeability questions actually now come into play. So if we are using products like AP foil or Corbon 3 or CI Max, right, because these things will be vapor barriers or vapor retarders at the thicknesses that we're talking about, we need to be sure we're putting enough on so that we don't need poly or craft or any sort of interior vapor retarder, right? That becomes an important piece. The wall system is going to work better when we can just have our vapor retarder be in one spot only. On the flip side, right, Cladstone is very vapor open, and so there it's okay, right? We could put enough Cladstone on to not need to worry about vapor being dealt with, or we could put on Cladstone and still put an interior vapor retarder on, and that's okay too because the wall can still dry to the outside. So that ends up being one of the big benefits that Cladstone brings. The messages really kind of hear the same in Climate Zone 7. It just becomes a little more so. I don't think we don't need to go into more of those details, right? It just ends up being another level. The continuous insulation needs to get a little bit thicker. So now we're going to take, for a minute, a little more of a deep dive into the individual products, right? So first looking at foam sheathing. So AP foil and CI Max, again, these are polyiso cyanurate foam boards. And, why would we specify these? Why would we use these materials? One is the high R value per inch, right? At 6 per inch, what this means is that we can use shorter fasteners to attach the insulation. It means that even just the cladding attachment systems themselves, right? Those could be Z-girts, those could be different clip systems, right? All of those things, these could be brick ties. All of those things can be shorter because we don't need as thick of a foam sheathing to get the R values we want. Also, these products are really easy to install, right? They come in board stock form. Lots of different trades can install these mechanically pretty simply, right? It can be sheathing guys, it could be insulation contractors, it could be somebody just that works for the GC, right? Could be putting these things up. Right, a lot of different trades can put these up without too much trouble. The other big benefit, again, comes in when we leverage these products to deliver our air and water and vapor barrier, right? If we tape these systems, if we integrate the flashing for windows and doors to these foam boards, we really get to bundle these functions all together, and it becomes a really slick system. Kind of on the wear, right? So these products can be installed on the exterior of really all wall types, right? These could go over steel stud walls, concrete block walls, tilt-up walls, you name it. We can put this stuff to the exterior of all those. It can be above or below grade with this sort of product, or it can go on the interior, right? So especially with concrete and mass walls, right, we might want foam sheathing on the inside, especially if we're going to use just the outside of that concrete as the exterior of the wall, or if it might just get an adhered stucco or something like that, right? We can insulate on the inside. One key piece to note there on wear is that CI Max can actually be left exposed, whereas AP foil has to be covered. And by covered, I mean typically with drywall or some sort of interior finish that delivers some fire performance. The final thing I want to highlight on the AP foil is that if we're going to use that product on the outside of a wall and it's going to be part of the air barrier or the WRB, the 3M, the bottom bullet point there, the 3M 8067 flashing tape is the only tape that is currently part of our ABAA approvals. That may change in the future. It requires kind of another round of testing, large-scale testing on our part. So today, that's just an important thing to note, right? If the architect or the specifier has called out ABAA-approved systems, that tape needs to be part of what gets installed on the job site. Moving on to closed cell spray foam continuous insulation, that would really be our Corbon 3 product. And again, the why really comes back to the high R value per inch, right? Again, at 7 per inch, you can use even less material to get your R value targets. And then the other big piece is because it's spray foam, you are definitely going to be leveraging and getting the air barrier and water barrier in one step, right? We don't need any tapes. We're just going to spray foam right to the cladding attachments, which are usually already going to be there. It just goes up in one step. Again, on the wear, really all wall types, right? It could be concrete block, it could go on sheathing that's over steel studs, right? Any of these things will work. Can be on the interior too. Again, that's mainly going to be for concrete construction. If we do on the interior, then again, we need to cover that, right? We need to put gypsum board or something like that on the inside so that's not left exposed. Finally, or for the last kind of product category, right, mineral wool, this would be our Cladstone product. Why would we use mineral wool? There's a lot of good reasons to use this on as a continuous insulation. It is water resistant and drainable. Now that, what I've mentioned before, and it's important to highlight, behind that product, we do need to be sure that there is a water resistive barrier and our air barrier is going to be there, because we're not going to get it out of this product. But the drainable and the water resistance features means that very little water will actually get back to that material. So it should really promote, right, a long life for those systems. Again, it's vapor open, right? That really promotes drying kind of in both directions. And finally, right, the non-combustible aspect of Cladstone is really an important piece. Right, so this is good, when we talk about tall buildings, needing to be non-combustible construction, and also for any buildings, this kind of third bullet point, right, anytime we're in the what's called the wildland urban interface, or WUI areas, and especially in the western part of the U.S., right, there's been a lot of wildfires over the last many years. There's a lot of rebuilding going on in those areas. And as that rebuilding occurs, WUI codes are being enforced more and more. Cladstone is an excellent option for those buildings in those areas. So now, as we're getting into the wrap up, right, a few examples, right. First, JM polyiso. So the first slide here, we've got some examples of buildings where we've got AP foil, right, on the outside of the building. Most of these, right, are shots of commercial buildings. The upper right is actually of a home. And there, the highlight, the thing to emphasize is that when we put foam sheathing on the exterior of a building and then tape all the seams up, what we really get is a very, very airtight building. This sort of approach goes a long way towards hitting our air leakage targets that building codes have anymore. On the flip side, right, again, as we talked about, we can put polyiso on the interior of buildings, and the photos here all are highlighting JM CI Max products. And the upper left photo, you can see there's logos and everything on CI Max, but the important thing to really note is that on the flip side, CI Max only has the printing on one side. On the back side of CI Max, it's blank. And you can get that blank in either a white or a shiny facer. And what that lets you do is let that really be kind of your finished surface, right? You can have this nice monolithic appearance, right, without a whole bunch of logos and writing on the wall, which can be a very nice thing. And again, CI Max can be left exposed. We don't have to cover this to comply with fire code. Similarly, right, some examples of buildings with exterior spray foam. Right, this can be steel stud infill, like the photo on the left. Right, you can see up above on that top story the gypsum board, the exterior gypsum board is still visible, or concrete block. I would say the main thing here is it does require skill, a skilled installer to do this well, and sometimes there's some protection needed to make sure that things like overspray, right, doesn't drift down onto vehicles and things like that. Finally, Cladstone on the outside of a building. Here we see this kind of orangey red sheet good that's on this gypsum board. That's the WRB and air barrier for this particular wall system. And this is actually one that's I think that's also vapor open. So the idea with this building is, right, it'll be able to dry in either direction, but that red layer is what's going to be kind of the final barrier against any sort of rain or air infiltration. So just getting into the wrap-up section, right, we've talked a lot about different product types, how they get used, and so this is kind of the final pros and cons of things. So first, if we look at AP foil, really AP foil or CI Max, right, the best climate zones, I would say these products really work great in all climate zones, right? The pros, again, high R leads to less thickness needed. Again, they can bundle up our WRB and air barrier functions. Pro can be that it's a vapor barrier, though we see that that's also potentially a con, and they're really pretty simple to install. Right, on the things to have as a watch out is, again, the vapor barrier, especially if we're in cold climates. Right, we don't necessarily want AP foil on the outside of our wall and poly or visqueen on the inside. And then finally, right, the fire approvals, which are kind of I feel like it's getting pretty ubiquitous. People are pretty aware of that, but it's just something to pay attention to. AP foil does have a bunch of fire approvals for many different cladding types and assembly types. Similarly, Corbon 3, I've got it listed as best climate zones as 3 through 8, and that's not that this is a bad product for climate zones 1 and 2. It's not. It's that once you get to climate zones 3 and higher, the R value required by the energy code calls for at least an inch of Corbon 3, which means then we're also getting the air barrier and WRB functions out of the product. We could still put that in climate zone 1 or 2 and it completely works, and it actually then means that the wall system is a little over-engineered versus what the code calls for, and then maybe that gives an opportunity for trade-offs in other areas. On the cons, again, same thing on the vapor retarder. I would say the biggest one is, right, skilled install is needed. Right, I mentioned that a minute ago, bears repeating. Really, you don't want a new hire pulling the trigger on the foam gun when we're trying to do Corbon 3 on the outside of a building. Finally, Cladstone, again, I've got best climate zones as 4 through 8, and I think that's really driven by the water vapor performance, right? So 4 through 8, those are cooler climates, especially if we talk about the Pacific Northwest. That's a very cool and wet climate. And so having that kind of ability to dry in both directions is huge, right? Not that these products can't work in the South. They absolutely do. The wall system just needs to be designed appropriately. Finally, getting into our last couple of slides, right, just trends, right? What else is coming? What things are changing as we look at continuous insulation? A big one is that the codes like ASHRAE 90.1 are going to start looking at structural members that they've kind of ignored up till now. So today, continuous insulation really gets at framing. Not as much at things like parapets and balconies and floor slab edges and things like that. I will tell you those changes are coming, so watch closely. Also, systems like cladding attachments, right? Great resources from firms like RDH Building Science and Morse and Hurstfield, and actually these images come from a kind of a document that is freely available from these firms, looking at, so the infrared image at the top, right, shows 2 different cladding attachment systems. So on the left, you can see thermal bridging still coming through the cladding attachment. They were Z-girts, right, versus on the right, it's a different attachment system, and so we get better performance. And there's a lot of different ways to attach claddings, and that becomes an important consideration. I think maybe more on the designer and specifier versus the contractor and distributor, but that's kind of what drives some of these decisions. So to kind of wrap up as we move over into taking questions from everybody, right, we talked about how continuous insulation manages thermal bridging, manages condensation from a number of different sources. Right, and the codes, it's really the energy code, right, is what's demanding continuous insulation on commercial buildings, though there ends up coming along for the ride a lot of other benefits related, again, to things like indoor air quality and condensation control. Fire codes obviously can be driving our product selection, right, whether we're talking about combustible foam plastics versus mineral wools, right, there's a lot of Johns Manville in particular, right, we've got a lot of product options out there, right? We've got 2 different types of polyiso foam board. We've got our Corbon closed cell spray foam. We've got our Cladstone mineral wool. Those materials couple up with the rest of Johns Manville's building insulation portfolio to really result in an almost infinite number of combinations that can be put together to successfully insulate a commercial building wall, right? And then finally, right, as we hit on before, products like AP Foil, CI Max, Corbon 3 also deliver additional functions, right? They can be air barriers, they can be water resistant barriers, and being able to bundle these functions together really can result in some good savings to the project as a whole, and, from reduced labor, reducing the number of times that trades have to touch a given square foot of wall, right? Those can all be good, definitely good things to consider. And so with that kind of concludes the main part of the talk.
Thank you so much, JR. Please reach out to your local territory manager for more information on our accessory products and to learn more about our specification specialists and technical services. Thank you very much for attending today. We hope you found the information useful and relevant. Take care and enjoy the rest of your week.